Perfect. All right. Hi, everyone. Thanks for coming. I hear there is a pub crawl going on right now, so sorry that you are not at it and you are here, but I'm very excited you're here. I'm Veronica Mapes. I'm the Technical Program Manager for Human Computation and Measurement at Pinterest, which encompasses, Pinterest, which encompasses all of our human evaluation and crowdsourcing efforts. And I'm here today to talk about humans versus machines, but more specifically, how Pinterest has leveraged Mechanical Turk to improve the content that we provide our pinners. So like most internet companies these days, Pinterest has a wide range of types of content. Our key component is a pin, but at the core of that pin is an image, and that image has objects in it. Those objects have labels. And the pin itself is related to different search queries and topics and annotations. And before a machine is smart enough to understand the connections between all of these pieces of content, a human has to actually sit down and create those connections. And that's what we at Pinterest think of as human eval. It's the process of having multiple people perform microtasks to solve a larger problem. And those microtasks tend to be labeling content. And the larger problem tends to fall into one of four categories that we rely on for human eval. I'll walk through each and give an example of how we've leveraged human eval in this way to improve the product. The first one I'll talk about is labeling content for training and testing machine learning models. And we actually use this for a lot of different areas at Pinterest, but the example I'll walk through is for Pinterest ads, or what we call promoted pins. So if you know anything about Pinterest, you know it's a site about inspiration and discovery. People come to Pinterest to find things that they might not know already exist, but that they want to act on in their real lives. So they come looking for dinner recipes. They find a recipe pin that they really like. They take the ingredients off of that pin itself. They walk down to the farmer's market, buy the ingredients, make that meal for dinner. Or they see a pin of a living room scene, and they're really inspired by the atmosphere in that scene, and they want to recreate it in their own living room. And they want to buy that couch and the same coffee table, and even paint their walls the same color as the walls in the pin. And these online moments of inspiration are really unique to Pinterest. And when you think about it, you realize that that's the exact same goal of advertisements. How can we reach someone when they're in that exact moment of inspiration that they want to act on something and purchase it? And when you realize that, you see that Pinterest ads can perform just as well as our organic content, assuming that the ads are highly relevant to the inspiring moment. So earlier this year, our ads team wanted to better understand the relevancy of the ads we were providing our pinners with. And they rated the text annotation relevance through human eval of over 700,000 of our promoted pins. And they used the collected data to improve the precision of our text signal by 16%. And that, in the end, realized an increase in relevancy of different types of pins and different placements of those promoted pins by between 20 and 70%. And these numbers were so impactful for the team that they're actually now tracking towards a human eval metric for one of their key goals. The second use case I'll talk about is labeling content for general content curation for marketing events or engineering services. And the example I'll talk about is content curation for our dictionary service for Explore pages. So every day, people come to Pinterest and they type in search queries that we may never have seen before, and we need to decide if we want to create an Explore page for that query. And an Explore page is pretty much just a topics page that renders the best content that we have related to that query. But Pinterest has pretty strict policy guidelines, and we don't want to create Explore pages that are policy breaching. So what we do is every single day, we look at all of the queries that are coming in by volume, and we run them through expansion and filtering services to get a subset of these queries that we have never seen before. And we run those queries through human eval, and we ask raters to tell us if they're inappropriate or appropriate based on our policy guidelines. Any queries that are deemed appropriate, we add into our dictionary service, and we create an Explore page for them. And any queries that are deemed inappropriate are added to our blacklist in our filtering step. A third major use case for human eval at Pinterest is for time series measurement of data. So as you can imagine, search is a really important aspect for a company like Pinterest. And we hit over 2 billion idea searches a month earlier this year. And that's a huge number. We're really proud of it, but we obviously want to increase that number. And the only way that you can increase that number in a good way is by making sure the relevancy of the results you're providing for your search queries are improving over time. The only way to know if your relevancy is improving is to track it against a baseline relevancy metric. So what we do is every single week, we take the top 20 pins that render for a random volume-based sample of head and tail queries, and we run them through a human eval job that looks like this. Is this pin relevant to this query? And in the end, we're able to aggregate across the highest performing and lowest performing queries a general relevancy score for that week. And as we start doing this over time, we can track how we're doing every week. And obviously, you would like to see these lines going up over time, because that would mean that your relevancy is improving. But I'm actually showing a chart that has a major anomaly in week 10 to show you how valuable doing human eval in this way can be. If you're a search engineer and you come in and you look at the chart and this week the relevancy decreased pretty significantly, you obviously know something went wrong and you should dig in and figure out what's going on. The fourth major use case for human eval at Pinterest is for A/B experimentation. So Pinterest is pretty fond of running experiments on both front-end UI changes as well as back-end algorithm changes. And every time we have an experience we want to test out, we launch it to a really small set of users, and over some amount of time, we make sure that none of our metrics are negatively impacted, and then we increase the number of users who are triggered into that experience. But sometimes our experiences can be really controversial, and we risk putting users into a really negative experience that has a lasting impression. And so what we introduced was actually doing offline human eval on certain types of A/B experimentation. So take a search ranking algorithm, for example. We're now able to take all of the queries that had the highest churn in pin results because of that experiment that we're testing out, and render treatment and control experiences side by side so that we can ask a rater which experience is more relevant to a query. And then in the end, we can aggregate that experience's overall relevancy to decide if it's going to be positively impactful on the end user's experience. And we can do this without impacting our actual users. So we've been using human eval for these use cases for a few years, but it really started to take off in early 2016. And even just in the first 6 months of 2017, you can see how significantly we increased our usage of human eval. But how did we get here? How did we get to be a company that relies so much on human eval? And to talk about that, I'll go back to early 2016. We had no human eval engineering team at the time and no human eval program. The engineers who are part of our human computation team now were actually part of the search tooling engineering team back then. And their search product managers started coming to them with their human eval requests. They just felt this team was the natural owner for these requests. But the team was so minimally resourced that they weren't able to own the requests from start to finish. And then over time, as the requests got larger and the number of requests increased, the team wasn't even really able to sit down with those product managers and make sure they understood how to use any of the platforms, the human eval platforms that we had been contracting with. So what would happen is people would come to us and tell us about a human eval project they wanted to run, and we would tell them which platforms we worked with provided the functionality that their project required. But then it was really up to them to go figure out how to use that platform, how to create templates, how to launch their job, analyze their data. And it was pretty unreasonable for us to think that these product managers had the time to be able to do that. We were working with 4 different platforms at the time, all of which had pros and cons, and we couldn't assume that product managers would actually sit down and learn the ins and outs of all of these platforms. And then even worse than that, a lot of the projects were actually fairly simple and required pretty traditional question types. And so multiple of the platforms would work just fine for their projects. So they'd ask us which platform had higher quality results so that they could narrow it down between 2 or 3. And we had no idea. We had spent most of our time up until now focused on making sure we had platforms that provided all the functionality that our customers needed, instead of focusing on which platforms provided the highest quality results. But at this point, we figured that that was not a way that we could continue operating, and we decided to focus on some quality analysis. And 2 of these platforms we actually use for pretty advanced functionality, like drawing bounding boxes around objects. So we decided to start with the 2 platforms that we used for our most common English language content. One of which was Mechanical Turk, which at the time we were only using for about 5% of all of our human eval work. And then the second one is what I'll call Platform 2, which is the blue piece of the pie. And we were using them for about 70% of our work. So to compare the 2 platforms, we had an internal group of people create ground truth data sets across some of our most common English language templates. And we launched jobs on both platforms with as similar configurations as we possibly could, so that we could see how the platform impacted accuracy and blacklisting rates, which in the end would also impact overall cost. And when we looked at the data, it was clear to us Mechanical Turk did a lot better across accuracy and had lower blacklisting rates, and so therefore also had lower cost. And this would imply that we should be using Mechanical Turk more than the 5% that we were at the time. But Mechanical Turk's UI, I don't know if you're very familiar, but it's a little difficult to use as a first-time user. And at the time, like I said, it was just when human eval was really starting to pick up in early 2016. So all of our customers were first-time users. And we couldn't assume that they had the time to sit down and really learn how to use this platform. So for this and a few other reasons that I'll talk about in the coming slides, in the middle of 2016, we actually introduced an internal self-serve human eval platform that we call Sofia that allows our customers to come in and build reusable templates on whatever functionality our engineers have built internally, and then launch jobs to whatever external platforms we've integrated with through their API. And this made it so that we no longer had to concern ourselves with what functionality external platforms had, because now a Sofia template would render in an iframe on these external sites. And our customers could actually go back to focusing on what really matters, the quality of the results that we're collecting. And when we introduced Sofia in the middle of June of last year, you can see how quickly we changed our usage of the 2 platforms that we compared for our English language content. Our usage of Mechanical Turk increased pretty significantly over the rest of the year. And then platform number 2, we almost entirely stopped using in 2016. And in 2017, we actually have entirely stopped using for English language content. And if you take a step back and you don't just think about English language content, because we're doing human eval in a lot of different areas, and you look at year-over-year growth from early 2016 to early 2017, our usage of Mechanical Turk actually increased by 184% and is now about 77% of our overall human eval efforts. So let's chat about Sofia, this platform that we built, why we built it, how we've leveraged it, and how we've leveraged platforms like Mechanical Turk since. Throughout building it, we had 4 key goals that we continued to track towards along the way. The first was that we wanted a really simple self-serve UI so that anyone at the company could come in and create whatever templates that they needed for their project without any upfront costs. The second was around template functionality. We wanted to be able to leverage our own engineering team to build whatever advanced functionality our customers needed so that we could shift to company priorities faster. The third was around results quality. Because we'd been working with so many different external platforms, we had no consistency in the quality of the results we were collecting. And then the fourth, for reducing costs, we've seen a pretty significant increase in our human eval budget since 2015, but we're always trying to do what we can to get more with the budget that we're given. Now, I'm not going to talk about the UI. If you can just take my word for it, it's pretty simple. It doesn't take that much to learn. But I will go into the other 3 goals and talk about a few different initiatives we focused on in each area. And I do want to take a second here before I get into everything to say that just because this is the approach that Pinterest took does not mean it's something that you necessarily have to do in building your own platform to get these initiatives I'll talk about. A lot of them might already exist on external platforms already. So I do encourage you, if something's interesting to you, stick around and talk to other people in the room, figure out what platforms they're using and what functionality those platforms provide. Because for sure, some of this stuff you can go back to your offices next week and start using right away. So for template functionality, most of the platforms we worked with provided all of the traditional question types that we needed, like radio buttons, checkboxes, dropdowns, things like that. But a lot of our customer requests were pretty advanced, and we wanted to be able to shift our own engineering resources to build whatever functionality they needed at the time, so that we could shift to whatever priorities our company was focused on. And the first real driver for us here was the ability to render pins the way that they appear on Pinterest. So yes, a pin at its core is an image, but it actually appears differently depending on what type of pin it is and what feed it's in. Some pins have titles and descriptions, some have in-stock and out-of-stock information and pricing, and then we have recipe pins that have the actual ingredients on the pin itself. And we needed to be sure that the labels that we were collecting on those pins were representative of the full experience a pinner sees when they're on our site, and not just one aspect of that pin. And we knew that this was something that no external platform would prioritize in building, and something we had to take into our own hands. As for advanced question functionality itself, this is an image that you saw earlier when I was talking about the A/B experimentation use case. This is a template that we built in Sofia that we call a side-by-side template that allows us to render two different experiences right next to each other and ask raters which side is better against something like a query or a topic. We're able to randomize and track which side the two experiences show up on. And then in the end, we can aggregate the overall quality or relevancy of the two different experiences and decide which one is better. This third one that I've called object identification actually includes three different key template features or functionality that we wanted to build in Sofia. Selectable pin grid, drawing bounding boxes, and asking for judgments iteratively. So we use this for a product initiative that we have that's called Shop the Look, where a pinner might be looking at a pin of a bedroom scene, like the one on the left, and decide that they really like that headboard and they want to purchase it. And so Pinterest wants to provide them with product pins that match that object in a non-product image. So what this means from a human eval perspective is that we wanted raters to be able to look at an image and draw bounding boxes around objects in that image and label the objects. And then by using a selectable pin grid, like what you see on the right, have them select product pins from our inventory that map to the original object. But because we wanted to increase the recall of all of the objects in the image, we wanted to be able to ask for people to rate this iteratively. So we'd ask one person to do a certain amount of the work, and then we'd ask a second person to look at the work that was done and say whether or not more work needed to be done so it could go back through for a second iteration. Our third goal of results quality is actually really important to us. Because we'd been working with so many different external platforms, we knew that there was no consistency in the results that we were collecting. But now that we're working with Sofia and we're able to standardize some of our quality initiatives on Sofia's end, we're much closer to guaranteeing a certain level of reliability across all of our human eval projects. And we actually start at the very beginning of a human eval project. Before a project owner is allowed to officially launch a job to the crowd, we ask that they go through a template validation process that we call a crowd accuracy test. And the gist of it is that we want to ensure the crowd understands the task that we're actually putting in front of them. So we ask the project owner to create a ground truth data set based on the template that they've created and are providing to the crowd, and then launch that job to the crowd. And we calculate the crowd's overall accuracy score so that we can use that as a pretty fair and reliable signal for how reliable the data will be on that template for future job runs. If the crowd accuracy score is pretty high, that implies to us that the crowd understands what we're asking them to do. But if the crowd accuracy score is fairly low, we ask the template creator to go through and review all of the disagreements that the crowd had and come away with patterns from those disagreements so that they can improve the template instructions. Sometimes this process only requires like one go. Some of our projects have had to actually go through 8 or 9 different iterations before we reached a level of alignment with the crowd that we were happy with. A second initiative we focused on was around the aggregation strategies that we used to decide what the crowd's overall quality was. Initially, when we were working directly on all of these external platforms, we'd look at the crowd's overall accuracy. So how often was each unique answer that we collected from the crowd, how often was that correct against our ground truth data? But once we started working with Sofia, we were collecting all of the answer data in our own database, and we could play with it a little bit more easily. And we immediately started looking at how the majority voting aggregation changed our understanding of the crowd's accuracy. So instead of looking at each unique answer that we collected from the crowd, we now look at the majority vote for each unique question that we collect from the crowd. And when we did that across a few of our major, most common templates, you can see that the majority voting aggregation showed that the crowd's accuracy was a lot higher. But we thought that we could actually do even better, and earlier this year, we asked a data scientist to build out an expectation maximization model that puts more weight on answers from workers who tend to agree with the crowd more often than answers from workers who tend to disagree with the crowd more often. And you can see that the expectation maximization aggregation strategy does slightly better over even the majority voting aggregation strategy. And these aren't the only 3 that you can test out, and we're still experimenting with which one we think is the best for us and plan on doing a lot more analysis around this in 2018. So this quality initiative that I'll talk about for blacklisting, the example I'll go into might be fairly obvious, but I still kind of wanted to talk about it. I still think it's a valuable lesson. So when we started collecting all of our answer data in Sofia's database, we could cut and slice it however we wanted. And we started to notice that across a lot of our jobs, we had a lot of workers who were always answering the exact same answer option every time we asked them a question. So in a, is this pin relevant to this query question, they were always saying, yes, the pin is relevant. And we came up with a pretty naive metric for them, and we called it %1. So if you're high up on the %1 scale, you are more often than not selecting the exact same answer option. And we felt there was no way that our data was so skewed. So we decided to look into the data, and we looked into the workers themselves, and came away with the idea that they just must be spammers. They are not really paying attention to the task that we're putting in front of them. They're just answering whatever the very first answer option is. And we wanted to eliminate these spammers. And the easiest way to do that was by implementing some type of blacklisting strategy where we insert one test question into each assignment that a worker works on. And if they fail that test question, their work is thrown out, and they're disallowed from continuing to work on that project. But the key here was that we needed to make sure that our test questions were fully representative of the data set, as well as the answer options that we're providing the workers. So in the pin to query pair example, we now needed to make sure we had 50% of our test questions were yes, the pin is relevant, and 50% were no, the pin is irrelevant. And when we did this, you can see we got rid of all of those spammers. And our thinking behind it was that the people who were high on the %1 chart, they would then see these test questions, and they would be more likely to see a definitively irrelevant pair. And so that if they are not paying attention and they actually are spammers, we will block them from our job. And again, like I said, the example might be obvious, and our blacklisting implementation might be fairly naive, but just doing that naive implementation definitely improved the accuracy we were getting from the crowd. The last quality initiative I'll talk about is around qualifications, and this is actually something that Mechanical Turk is a pretty strong leader in. And the idea here is that if you select workers who are really high quality, the content labels that you collect from that hand-picked crowd are much more reliable than the labels that you collect from a generic crowd. And when you look at the data, that's exactly the case. If you compare the general crowd to each individual really high-quality worker, or then to the group of that high-quality workers, you see how much impact you can get from the qualification. And it doesn't just have to be people that you have found to be really high quality. It can be something like you're looking for people who have a certain level of expertise in something that you put into a qualification. Our last goal of reducing cost is something I'm sure everyone in this room has thought about. And like I said, we've had a pretty significant increase in human eval budget since 2015, but we're still trying to do whatever we can to reduce the costs. And the first initiative we focused on was around objective test questions. So historically, we didn't provide much guidance to project owners in creating test questions. We just let them do whatever they thought made the most sense for their job. But project owners tended to always be in a hurry, and so that meant that their test questions were created somewhat haphazardly. They'd answer in a way that they thought was right, but without the right level of concentration, that can be somewhat arbitrary. And we noticed that it was even inconsistent across project owners from the same initiative. And what would happen then is workers would come in and work on an assignment, and they'd see one of these arbitrary test questions, and they would fail it, and their work would be blacklisted, and they would no longer be able to participate on that project. And while their work is going through review, because we prioritize for job completion time, we'd actually request another worker redo all of the currently blacklisted work. But if that first worker ended up being blacklisted for an invalid reason, we'd pay them for the work that they did, so we'd end up paying two people for the same work. And this was clearly a waste of money and something that could easily be solved if we had the product managers or project owners focus a little bit more on the test questions that they were creating up front. And to prove the effort would be worth it, we categorized the agreement level of 5 different internal employees on a ground truth data set into weak, strong, and unanimous data points. And we compared the crowd's accuracy to the entire data set, as well as the crowd's accuracy to just the strong and unanimous agreement points. And when we did that, you can see that the filtered accuracy, so the filtered accuracy without the weak agreement data points, the crowd had a much higher accuracy there. And if you see that that's representative of high ambiguity test questions, and we filter out those high ambiguity test questions, you can assume that workers would be less likely to fail these test questions, right? They'd have higher accuracy on our test questions, which would reduce the blacklisting percentage and reduce overall cost. Another area that's always up for debate, and so it's a really great one to experiment with, is how to decide exactly what to pay your workers. Every time we have a new human eval project, we reverse calculate the price that we pay by evaluating how many tasks we can do in an hour and then adhering to minimum wages. But that's fairly arbitrary. The number of tasks I can do in an hour is not the same as someone else on my team. It's also not the same as someone in the crowd. Some people are really fast and they can do twice as many tasks in the same amount of time. Some workers are new to maybe our projects and take twice as long. So we recently spent some time analyzing if there's an optimal price to pay for some of our most common templates. We thought that too low of a price would increase job completion time, and too high of a price would attract spammers and bots and low-quality workers. So we took one ground truth data set, and we ran it through human eval 3 times on each of 8 different price points, controlling for a bunch of different factors so that we could see how price impacted blacklisting rates, accuracy, and job completion time. And when we looked at the data, and as you can see in the charts, all of these metrics started to taper off around the 20 and 40 marks, which based on the numbers that we're working with, meant that we could reduce the price we were paying for one of our most common templates by 50%. And this template that we're using is one that we actually use for the time series measurement use case that I talked about earlier, which means that we run it once a week in each of 6 different locales. So if we can reduce the price of one of those job runs by 50%, you can imagine how much cost savings we'll get in a full year. As for functionality that we actually built in Sofia, dynamic judgments is the ability to adjust the number of people you ask to rate the same question based on the agreement level of the answers you have already collected for that question. So the idea is we can ask 2 people to tell us if the pin is relevant to the query. And if they both say, yes, it's relevant, we have high confidence that, yes, that pin is actually relevant to that query. But if they disagree, we can dynamically ask 1 or more people to rate the same piece of content so that we can reach a higher level of confidence in that answer. And the reason we built this was because after we moved to Sofia and could play with our data a bit more, we started to notice that a majority of the final answers that we were taking from the crowd had unanimous agreement. And when I say majority, I mean that upwards of 80% of the data points that we took back as the final answer had 100% agreement across 3 or 5 people that were rating it. And so by implementing dynamic judgments, we actually remove the need to pay for a third worker to rate content that we are already extremely confident in. Another cost savings area we focused on was limiting the number of assignments that one worker can participate on at the same time. So based on the way that we're integrated with external platforms, one internal human eval job actually creates multiple external human eval jobs. So in Mechanical Turk terminology, one Sofia job creates multiple hits that a worker can open up at the same time. And this caused some quality and cost problems for us. So the first was that we would launch a human eval job, and it would create multiple hits, and a worker would open each of those hits at once, and then leave those links open for hours at a time and come back whenever they actually had the time to complete the work. Because we optimize for job completion time, we built in an abandonment workflow. So if an assignment is not actually submitted in a certain amount of time, we release that work back to the crowd and ask that someone else do it. Unfortunately, this obviously increases job completion time because we have to wait for that abandonment workflow to run. But it also increases cost because if that first person comes back and actually completes the work, submits the assignment, and passes our test question, we want to pay them also. So we end up paying 2 people to do the same work. The second issue is that if people open up a bunch of our links at the same time and work on our projects across hours and hours, they can hit a point of repetition fatigue where their quality just starts to decrease because they've looked at the same stuff for so long. And as their quality decreases, the chance that they'll be blacklisted increases, which increase costs. So for this and for a few infrastructure reasons, we actually implemented an assignment rate limit that disallows a worker from visiting a new assignment page if they have outstanding tasks assigned to them. What that means is just that they can only work on one hit of ours at the same time. And when we implemented this, you can see how much the blacklisting rate and then the cost per task decreased. And so it saved us tons of money since we implemented it. So I've talked about Sofia and how Pinterest has used human eval over the past few years. But what's next for us? Pinners come to Pinterest and they save content that they really like, and they follow other people who have similar interests as them. And we track all of the connections behind the actions that they take on the site so that we can provide them with a better experience in the end. But the question is, are we actually successfully understanding who these people are and what they like? So in 2017, we started moving towards doing personalized human eval. We built an in-app user communication platform that allows us to actually better understand how our content is perceived by actual cohorts of our pinners. And we're just getting started with this. So far, it's pretty promising. We've already used it to leverage our pinners to better understand the precision of our user profile annotations, which is a major piece of being able to render high quality and highly relevant ads. And we have a lot of other projects going on right now, too. So something we'll work on in 2018. Thanks for coming. My email address is veronica@pinterest.com if you have any follow-up questions. I'm here for a little bit longer. The timer didn't start right when I started, so I don't actually know how much time I have. It didn't start when I started, though. That's good? Cool, cool. So plenty of time if you guys want to do Q&A now, but I'm also happy to chat afterwards. Any questions? Cool. Thanks for coming.